So in this video, I'll discuss the concept of exact functions and differentials and kung paano ba sila na-apply sa ating thermodynamic systems. I will also discuss our new state function, which is the entropy function or the delta S. So paano ba siya na-derive and saan siya ginagamit and ano ang implications ng state functions na ito. Okay? So what are exact functions and differentials? So a function f of x and y, where x and y are independent parameters of f, is said to be exact if its total derivative given by this. So df is equal to the change in f with respect to x at constant y times change in x plus the change in f with respect to y at constant x times the change in y. So yan yung gradient niya. Okay? This total derivative, if this equation has this property, the function is said to be exact. Okay? So what is this property? The change in y at constant x of this particular change at constant y should be equal to the change in with respect to x at constant y of this particular change with respect to y at constant x. So kahit ano yung unahin mong derivative, kasi ang ibig sabihin lang niyan, yung f, okay, dinerivative mo, okay, dinerivative mo muna with respect to x, tapos dinerivative mo with respect to y. Ganyan yung nangyari. Okay? Dapat equal to dun sa f, okay, na dinerivative mo muna with respect to y, tapos kinuha mo yung derivative with respect to x. Okay? So, kahit ano yung sequence ng differentiation mo, dapat pareho pa rin yung value na makukuha mo. Okay? Dapat yung value nito ay equal sa value nito to be able to consider it as an exact function. Okay? So, all state functions, obviously, are exact differentials. Kasi, it doesn't matter kung ano yung path ng differentiation or yung path ng change. As long as yung function ay makakarating from state 1 to state 2, yun lang yung important. Because, we measure the state by the change only. So, for example, this particular change is equal to f2 minus f1. So, this particular path, okay, can be divided into its components x and y. So, pwede mong unahin yung change in y at constant x, tapos saka mo gawin yung change in x at constant y. Pwede rin gawin yung change in x muna at constant y and then do the change in y at constant x. Kahit ano yung unahin mo, as long as you will do both changes, makakarating ka dun sa f2. Okay? So that is for exact functions. So in summary, being an exact function means that the change, okay, is still the same regardless of the sequence of changes in x and in y. So path dependence is irrelevant. Okay? Hindi siya path dependent. Okay? So how do we apply this in thermodynamics? Meron tayong first law. Revisit natin yung first law. We know the values or the equations for du and dw, diba? So for du, we have cv dt. For dw, we have negative pdv. So for ideal gases, it's negative nRT dv over v. However, wala tayong equations for dq. So we will derive this in terms of dq or with respect to dq. Ano nga ba yung dq? I-define natin siya ngayon. Okay? dq is an inexact function. Okay? So, we will derive an equation na magiging exact functions lahat nung nasa first law of thermodynamics na term. So, since inexact yung function, magva-violate siya nung property na dinescribe natin kanina, itong property na to. Okay? Dahil hindi equal yung change in the volume of Cv dt. Okay? Hindi siya equal dito sa change with respect to temperature of negative nRT dv over v, which is already illustrated by this. So, hindi siya exact function because of that. Pero, interestingly, kapag dinivide mo siya ng temperature, gawin mo siyang ganito. Okay? So, if we divide the first law by the temperature, okay, this is a reversible expansion or contraction. Reversible PV work siya na nag-change pareho yung temperature and volume. Kaya, parehong present yung dt tsaka dv dyan. Okay? So, if we divide the equation by t, okay, mangyayari, yung derivative with respect to volume of Cv dt over t, magiging equal na siya sa change with respect to temperature of negative nR dv over v. Okay? Magiging exact na siya. dq over t or dq reversible over t is exact. Okay? Kailangan reversible kasi hindi magiging ganito yung ating work. Okay? Kailangan ganito yung ating work. nRT dv over v. P external is equal to P gas. Okay? So, dq reversible over t is a state function. Okay? So if it is a state function, it has to mean something. So we have to assign this a symbol. So the symbol for this is ds, or we also call this the entropy. Now, we will explore the properties of the entropy. So ano nga ba yung entropy? Okay? So ano yung mga entropy ng mga systems na isolated? Ano yung nangyayari sa entropy nila? So doon lang natin siya ma-observe kasi we cannot observe entropy changes directly kapag ginagamit natin yung mga normal PV processes na controlled ng surroundings. Okay? So gagawa tayo ng specific situations where we can apply the concept of this dq rev over t. Okay? So the first one is for the Clausius inequality. So si Clausius yung nag-formulate nitong concept na ito. So for an isolated system, meron din dalawang system na identical pero connected lang sila by this tube. So dito lang nagko-conduct ng heat yung system. This tube does not affect, okay, the amount of heat transferred from A to B or vice versa. So okay lang yan. So A and B are separate identical systems. So pareho sila ng heat capacities. Okay? So QA is for system A, yun yung ilalabas or ipapasok ng heat dito sa system A. For B, QB. So QB can be released or absorbed by T or by system B. So the temperature of A is TA, the temperature of B is TB, and the temperature of A is greater than B. So after some time, magkakaroon ka ng thermal equilibrium where all the temperatures is the equilibrium temperature TC. Okay? So the system is adiabatic, so therefore QA plus QB is equal to 0. Therefore dQA is equal to negative dQB. However, kunin natin yung entropy niya. Okay? So dSA is equal to dQA over TA. ds of B is equal to dQB over TB, or equal siya sa negative dQA over TB, since dQA is negative dQB. So what is the entropy of the system? So ito siya. Okay? ds is equal to dQA over TA. I-substitute na natin minus dQA over TB. So pwede nating i-separate si dQA para lumabas to. Okay? So ano ngayon yung magiging value ng ds? Depende yan sa dQA. Since TA is greater than TB, the value of this is less than 0 or negative. Okay? Negative yung value niya. So what if dQA is positive? So if dQA is greater than 0, then the ds of the system is less than 0. So ibig sabihin, kung dQA is greater than 0, if this is A and B dun sa system kanina, A is the one who absorb heat. Okay? dQA is positive. However, if ds is greater than 0, this means that the QA is less than 0. So ibig sabihin, ganito naman. So ito yung positive na dQA, ito yung negative na dQA. So ano yung mass or ano dito yung spontaneous process? Ano dito yung nangyari sa system? Okay? So we have assumed that the system would reach thermal equilibrium, mag-equal yung temperature niya. So ano yung dapat na flow ng heat? So ang dapat na flow ng heat, okay, for example, is the flow that would introduce or that would decrease the temperature of A and increase the temperature of B para magpantay sila. Okay? Paano yung mangyayari? So, tingnan natin yung dalawang scenario. Kung dQ is greater than 0, tataas ng tataas yung temperature ni A. At bababa ng bababa yung temperature ni B. Kasi sa B lang naman manggagaling yung energy na i-absorb ni A. So, the temperature difference will be greater through time, okay, which does not or deviates further from the thermal equilibrium. So, hindi ito nangyayari, itong situation na to. Ang nangyayari dapat ay nagre-release ng heat si A. So, the dQA should be less than 0. So, kapag less than 0, bababa yung temperature ni A, magkakaroon ng increase sa temperature ni B, but not much, okay? That, in the end, or at equilibrium, magkakaroon sila ng parehong temperature or parehong energies. So, this one is the one that should happen para lumapit sa thermal equilibrium. So, therefore, this particular system, okay, has a positive ds or a positive entropy. We know that this is the spontaneous process, okay? So, ibig sabihin, hindi natin siya kinontrol using outside force. So, this process happens by itself. Okay? So, in conclusion, spontaneous processes in isolated systems have a greater than 0 value for the entropy. Okay? So, yan yung implication ng entropy. So, ds decides or ds tells you the direction of the equilibrium. Saan papunta yung system? Saan equilibrium state siya papunta? Okay? So, in this case, malalaman nyo kung saan papunta yung heat depende sa value ng ds. So, the value of ds is positive kapag yung heat ay released by system A. Okay? So, therefore, that should be the spontaneous process. Okay? So, ano pa yung mga process na pwede natin gawing spontaneous at mag-evaluate tayo doon ng entropy? So, pwede natin gamitin yung Joule expansion process. So, sa Joule expansion process, ang gagawin nyo lang ay re-remove nyo lang yung barrier na yan para mag-expand yung gas sa vacuum. Okay? So, kapag nag-expand na siya sa vacuum, we expect this to be spontaneous. Okay? Because the expansion or the gas particles tend to press doon sa vacuum. I-occupy nila yung buong system. Okay? But does this have a positive or a negative entropy? So, check natin. So, the work is 0 and dq is 0 because vacuum, walang external pressure, and the system is adiabatic. So, therefore, the du is 0. And this gas is ideal. Okay? So, therefore, wala tayong change in temperature. So, kapag ideal gas, wala tayo nung phi t or yung change in the internal energy with respect to volume at constant temperature. Wala tayong ganyan. Wala rin tayo nung T, V, U. Wala rin tayong ganyan change. Okay? So, as the gas expands, hindi nagbabago yung temperature. So, how do we calculate the entropy? So, ang gagawin natin, mag-imagine tayo ng situation na pwede nating ibalik yung gas dito sa chamber na to by adding heat reversibly. Okay? So, tingnan natin. Ayan. So, sa diagram na to, binabalik natin lahat ng heat, kino-convert natin to sa vacuum by adding Q. So, babalik na siya dito ngayon. Nandito na lahat ulit ng gas. So, initially, okay, ang volume niya ay yung V2. So, V2 ang volume niya. Ngayon, ang final niya ay yung V1. So, bakit V1 dito? Kasi yun yung V1 dito. V2 is 2V1 dun sa initial situation. Okay? So, yan na lang yung aking mga labels. So, ibabalik natin siya sa V1. Okay? So, since the ds is a state function, ibig sabihin, kung i-add natin yung entropy nito, yung ds expansion, okay, tsaka yung ds compression, pag in-add natin tong dalawa, dapat 0. Okay? Kasi cyclic. Okay? So, ds expansion plus ds compression is equal to 0 kasi ibabalik natin siya dun sa initial state. So, dapat yung entropy nun, babalik sa 0. Okay? So, by adding heat, ito yung imagine natin, yung compression. Imagine. Ito yung in-imagine natin gagawin natin to reverse the process. This is the actual process. Okay? Okay? So, therefore, doing the ds compression, okay, this is at constant delta U, wala tayong delta U. This is isothermal process, okay? The reversible heat is equal to negative dW. So, dQ is equal to negative dW, which is equal to nRT dV over V. Ganyan. Okay? So, ang kailangan natin ay entropy. So, i-divide natin siya ng T. Okay? So, therefore, dQ rev over T is equal to nR dV over V. Okay? So, ito na siya. Okay? So, for the compression process, i-integrate natin both sides. So, pag i-integrate natin both sides, makukuha natin ay nR ln V1 over V2. Okay? So, yung V1, okay, that is 1/2 of V2. So, V1 is 1/2 of V2. Therefore, this value is nR ln, okay, 1/2 V2 over V2, which is equal to nR ln 1/2. This value, okay, is less than 0. So, therefore, the delta S of compression is 0. Okay? Kung 0 yung, or kung less than 0 yung delta S ng compression and the delta S compression is equal to the negative delta S expansion. Okay? Therefore, this one is greater than 0. So, ibig sabihin yung actual process, positive yung entropy niya. Okay? So, therefore, gases tend to occupy the volume of all available space spontaneously. Kasi yung expansion, again, yung delta S ng expansion, ng Joule expansion, is greater than 0. It denotes spontaneous events. Okay? Wala tayong outside force dito. Kasi, again, the system is isolated. Therefore, the process here has a positive entropy. Okay? So, that is for the spontaneous Joule-free expansion. Okay. So, na-discuss ko na yung spontaneous heat transfer at spontaneous Joule-free expansion. So, summarize ko na. For entropy, okay, entropy is the state function delta S is equal to the integral of the dq reversible over t. So, therefore, okay, since that's dq rev, this can only be calculated through reversible paths. Kailangan yung q nyo ay reversible. Okay? The sign of delta S indicates the direction of the spontaneous process. So, na-exhibit ko na kanina using yung dalawa nating experiment. So, kapag positive yung delta S, happens spontaneously. Pag negative, may influence ng external force bago mo mai-undergo yung system sa ganung process na gusto mo. Okay? Meaning, kailangan ng external force. Kapag non-spontaneous ang process, to be able to do that, kailangan mo ng assistance ng surroundings or external forces from the surroundings. Okay? It requires external influence. So, if delta S is equal to 0, ibig sabihin, it means that the Q reversible might be equal to 0. Okay? Meaning that the process undergoes an adiabatic reversible process, expansion or compression, whatever. Okay? Or, the system is already at equilibrium. Wala nang exchange ng heat, wala nang expansion or compression ng gas na nangyayari, etc. Okay? So, kapag nasa equilibrium state na siya, 0 na yung magiging entropy. Okay? So, from the first law, we can derive the values for delta S or expressions for delta S. Okay? So, from the first law, du is equal to dq rev plus dw. We can equate this to dq rev equals du minus dw. dq rev over t is d over t plus nr dv over v for ideal gases because this is from the ideal gas equation, diba? nRT dV over V divided by T, that's nR dV over V. So, ds, since du is CV dt, okay, dq reversible over T is CV dt over T plus nR dV over V. So, integrate natin to, makukuha natin yung delta S, CV ln T2 over T1 plus nR ln V2 over V1. So, this is entropy in terms of the temperature and the volume. Na-derive natin siya from U na function ng temperature and volume. Okay? So, next, for enthalpy, delta H is equal to dq rev plus VdP. So, pagpalitin din natin to, itong dalawa. Makuha tayo ng dq rev is equal to delta H minus VdP. So, divide natin by temperature. Delta H is equal to Cp dt, diba? dH is equal to Cp dt. V is nR dP over P, ideal gas again. So, V is equal to nR T over P. So, wala na yung T kapag V over T, diba? Kasi, divided na siya ng T. So, negative nR dP over P. So, integrate natin to. Okay? Delta S is equal to Cp ln T2 over T1 minus nR ln P2 over P1. This is S as a function of temperature and pressure. Derived siya from HTP. Okay? So, that is entropy in terms of temperature and pressure and entropy in terms of temperature and volume. So, sa susunod na video, magkakalculate na tayo ng mga entropies ng iba't ibang PV processes. Siyempre, i-derive din natin yung mga entropies ng mga PV processes na yon and manggagaling siya sa dalawang equations na ito. Okay? So, see you next video.